Hey guys, welcome to lesson 411. We are at the start of unit 4 where we'll talk about solving different kinds of equations that are really kind of centered around finding intersection points between graphs. So for our first problem here, we have given you the graph of this x plus 3 squared minus 5 equation. And what we want is to find the solution to an equation that is 4 equals x plus 3 squared minus 5. So really we just took that one that we gave you the graph for, set it equal to 4, and we want to solve this. Okay, now when you do this, you can do it using the graphs. And what I mean by that is you can take the right side, call that one of your graphs or equations. We're going to call it y1. It doesn't matter which side you pick as your y1 and your y2, but I like to pick the more complicated one to be y1 just because. All right, so let's try it again. It's kind of ugly. Okay, now y2 would then be the other side of the equal sign. So in our case, it's going to be this 4. So y2 equals 4. The 1 and the 2 are just to help us remember which one's first, which one's second. Really, it's the same thing as just y equals 4 and y equals this other equation. So I already gave you the graph of that first equation. So let's go ahead and create the graph of y equals 4. Because it's just y equals a number, it's a pretty easy graph to draw. Anytime you have y equals a number, it's just a straight horizontal line that goes through that number on the y-axis. So here, because we have y equals 4, it's going to hit the y-axis at 4. So now, when we're finding the solution, the key is to find the points of intersection. So here, we can very clearly see that these two graphs intersect at this point and at this point. But because we are just trying to find the solution of this equation, we can see that there's just an x missing in an equation. And whenever you solve an equation, really you just want to find out what x equals, right? So our answers are not the points of intersection, but rather they are the x value or x values of these points of intersection. Those are pretty bad lines, but we tried. So at -6 and 0, we can say that those two equations will be equal to each other because those are the points where they share y values, okay? So if we were to solve this algebraically, which as you guys have probably realized by now, we can always do things in multiple ways. We are going to want to move things around in this equation. Now, this is the same exact equation we just solved graphically. We're going to move stuff around to try to get x alone. So here, if we look at this part, x plus 3, that's all kind of stuck in these parentheses because it's being squared. But what we can do is move this 5 over by adding it to both sides, since it's minus over here, and start our journey of getting the x by itself. So now that leaves us with x plus 3 squared on the left and 4 plus 5 equals 9 on the right. So next, again, this is stuck in these parentheses because it is being squared. So the next thing we want to do is get rid of this squaring. And the opposite of squaring is to take the square root. So we're going to go ahead and take the square root of both sides. And on the left, that's conveniently going to just get rid of the parentheses and the square. And on the right, it's actually going to give us two answers. One's going to be positive and one's going to be negative. Okay, so we have positive 3 and negative 3. This is something that's pretty neglected a lot of the time and people kind of forget about it. But I do want to take a moment to explain why the square root of 9 has two answers. So when we square root something, we're pretty much asking ourselves, okay, well, what squared equals 9? And you might think, oh, well, obviously it's 3. But if I asked you what 3 squared equaled, you would tell me 9. And if I asked you what negative 3 squared equals, hopefully you would tell me 9. Both of these are equal 9. You can test it out when you put it in your calculator. Make sure you use parentheses around the negative 3. But because we just found two ways to square a number and get to 9, we have to include both of those answers when we square root 9. Okay? It would be bogus to just ditch the negative 3 when we know it's a valid solution. So at this point, we have to split this up into two pieces. And that's how we are going to be able to get two solutions, which makes sense because when we solved it graphically, we had two solutions, didn't we? All right, so now we can solve these both separately. Here we would subtract 3 from both sides and end up with an answer of 3 minus 3 equals 0. And on the right side, we would again subtract 3 from both sides. And this time we would have negative 3 minus 3, that equals negative 6. So, of course, we should get the same answer when we do it algebraically and graphically because we solved the same problem. But these are two different methods that you can do it with. All right, next problem. We have this equation right over here that we want to solve. Now, graphically, we do the same thing as we did last time, but algebraically, it's a little bit different just because we have a quadratic now, so we can't just move stuff around and solve for x like we did here. We're going to have to use our other quadratic methods, okay? Particularly factoring. Quadratic formula is also an option, but I'd rather not. So, I don't know if you guys remember this, but anytime I told you to solve a quadratic equation, it usually looked something like this. It would be like something along these lines, and then it was always equal to 0. Okay, you may or may not have noticed this, but every time I told you to solve one of these, it was always equal to 0. And that's exactly what we need to happen here if we want to solve it. Okay, so this, in order to get this to be like a equals to 0 format, and I'm going to write that here, okay, must get it to equal 0 first. We got to move something around, okay? Now, we could move everything on the right side to the left and empty the right side, but that would be kind of foolish when it would be much easier to just move the 6 to the other side. All right, because 6 minus 6 equals 0, that's what we wanted. If we just move everything away from one side of the equation, then you're just left with 0 there. And on the right side, we would have this. Notice how I combined the negative 6 with the other negative 6, because I can't subtract 6 from x squared. I can't subtract it from this negative x. It's only like terms with this number right over here. So now I have a regular quadratic equation, and I am ready to solve that, and I can do that by factoring. So we can go ahead and set up a box and diamond here. I tried. Okay, so now let's go ahead and set it up. Oh, I should have done the insides too. Okay, not bad. X squared goes in the first box, negative 12 down here, and then the diamond, we have first term times the third term. Down here we have negative x. I'm going to write negative 1x just to make it more obvious that we're looking for a negative 1. And of course, now we get to play the game. What two numbers multiply to make negative 12 and add to make negative 1? Hopefully, you would realize that those numbers are negative 4 and 3. So that's how we're going to fill in our box, or boxes. And now we can fill out the outsides. And again, I'm not going through this part particularly slowly by any means, because this should just be a part of our knowledge now. So remember that when you're solving by factoring, you have to actually go that extra step past just factoring. So now that we've factored it, we have to like set each part equal to 0 and solve each one. So here we would get positive 4 by adding 4 to each side. And then here we would subtract 3 from both sides and we would get negative 3. All right, so really the only new thing that I did here was subtract 6 from both sides to get it to be equal to 0. Other than that, everything else is familiar to you. So that's how you would do that algebraically. Graphically, though, we would have to do that method where we take the right side, we would call that our y1, and we would take, well, let's write that down first. Okay, and then we would take our left side and we can make that y2. It doesn't matter which one you call y1 and y2. Again, I just like to make the more complicated one y1. but it does not matter. Okay, so now that I've done that, I actually need to pull up my calculator, and I'm going to need to graph those. Okay, you just got to hit y equals, get to the screen. I have typed them here already just to save us a little bit of time. So I typed y1 in the y1 spot, y2 in the y2 spot. Let's hit graph. All right, so my picture's a little funky. I forgot to change my zoom setting to being nice. So I'll do that here really quickly. So here they will first graph the y1 equation, and then next will be the y2 equation. The y2 equation is a pretty simple one since it's just y equals 6. So if you look here closely at the picture, you can see that right here we have an intersection point, and if you carry it down, the x value is at the -3 tick mark. And then this intersection has, if you trickle it down, is at the +4 tick mark. So that tells you that your answers would be -3 and 4, which is exactly what we got when we solved algebraically. Another thing you can do, because you can't always trust these tick marks, they're not always the easiest to look at, you can go to second graph to go to your table. And here, if you just look for where the y1 and y2 columns are the same, you'll find your solution. So here, at -3, both of these columns are a 6, so that tells you that's a solution. Here, both of these columns are 6 again, which happens at 4. So that's another way you can know that -3 and -4 are solutions to this problem. Okay, so x equals 4 and -3, and we figured that out by looking at the graph. All right, on to the next. So here we want to solve this algebraically, and so we're going to go ahead and move stuff around to get x by itself. Okay, so the first thing we want to do is notice that the x is trapped in the square root, so we got to move other stuff around first. A good first step would be to move this 9. We can subtract the 9 from both sides. So the 9 is going to go away. We are left with 3 times the square root of 4x minus 8. And then on the right, we are left with 15 minus 9, which is going to be 6. All right, so now we want to move this 3. We can divide both sides by it because right now it's being multiplied. And that's going to give us the square root of 4x minus 8 equals 2. 6 divided by 3 is just 2. So now I know that my x is stuck in the square root, so we want to get rid of that square root. Okay, and the way to do that is to just do the opposite. So let's go ahead and square both sides because that's how we get rid of a square root. So 4x minus 8 then is what we're left with. And on the right, 2 squared is 4. All right, now we are ready to just solve this like a regular, nice and easy equation. We can add 8 to both sides. You get 4x equals 12. And the last step would be to divide both sides by 4. These would cancel, and our x equals 3. Okay, that is how you would find the solution of this algebraically. On a graph, again, we're running out of time here in my 15-minute limit, but y1 would equal well, let me do my blue. So we would have y1 would be here, and then y2 would be here. And you would graph it the same exact way, right? Put each one in the calculator and find the intersections. All right, and we have one last problem here. So we want to use our graphing calculator to solve this one. So I'm going to go ahead and pause the recording to type these in, because again, I am running out of time. All right, I've typed these in. I do want to just say that to get these absolute value bars, if you press second and then 0, that's the catalog button, that ABS is what you would press to get absolute value bars. But let's go ahead and graph this. I've just typed each of these into y1 and y2. As you can see, the picture's a little difficult to look at, so it would be in our benefit to just go ahead and go to this zoom button, and we can go to the second option where it says zoom in. And if we just scroll up here, I'm going to pause the video again because I'm still running out of time. So I zoomed in, I pressed enter, and I saw that the x value at this intersection is 0.51, and then if I scroll over here, it's 0.